So let's look at this question. A person observes a lightning flash which is followed by a thunder 3 seconds later. How would you estimate the distance of the lightning flash from the person? Let's solve this interesting question from physics, grade 12. During a storm, we see the lightning flash first and then hear the thunder a few seconds later. The question is if the time difference is 3 seconds, how far away is the lightning? Okay, let's solve it step by step. For that, we are given that the time interval between seeing the lightning and hearing the thunder is 3 seconds, as you can see here. We have written delta t equals to 3 seconds, right? The speed of sound is 340 meters per second. Let's write speed of sound, and let's denote it with Vs. Okay, speed of sound is denoted with Vs, and it is given as 340 meters per second. And the speed of light is 3 into 10 to the power 8. Speed of light VL, or you can simply denote it with C only, equals 3 into 10 to the power 8 meter per second. Now we need to find the distance of the lightning from this observer. Suppose on the ground here an observer is standing, and somewhere in the sky the lightning is happening, and the question is asking us to calculate this distance. So this distance equals to what? Okay, so let's write down distance d equals what? Now comes the important concept. Both lightning and sound travel approximately the same distance, because lightning and thunder are assumed to be happen from the same place. Okay, but light travels enormously faster than sound. So the light reaches the observer almost immediately. This observer almost immediately. Okay, while the sound takes some time to arrive. Light approaches immediately, while sound takes some time to approach this observer. Okay, therefore the 3 second delay is the difference between time taken by sound and time taken by light, because sound takes more time than light. Okay, so from the equation we can see here, we can write delta t equals time taken by sound minus time taken by light, equals, we are given the difference between the time is 3 seconds, so simply you can put 3 over here, and then let's say distance divided by velocity of sound is the time taken by sound, minus distance divided by velocity of light is denoted with the symbol c. Now let's take common d. You will get 1 by Vs minus 1 by Vc, simply c. Okay, it's 3, or 3 equals d. 1 by Vs is 340 minus 1 by c is 3 into 10 to the power 8, or you can simply calculate d as 1020, approximately 1020 meter. So let's calculate it with using calculator over here. You can see 1 by 340, So let's take fraction. 1 by 340 minus 1 by 3 into 10 to the power 8. It will be something like this. And if we divide 3 with the answer we got recently, and you can see the answer is 1020.001. So we can skip the 3 digit after the decimal. So it will be 1020 meter. Okay. So the lightning flash was approximately 1020 meters, or about 1.02 kilometer. So if you want to convert it into kilometer, it will be approximately 1.02 kilometer away from the person, from this person. The lightning is happening about 1.02 kilometer away. Okay. There is also a very useful shortcut. So let's talk about this shortcut also. So how can we calculate it using a shortcut method? Because the speed of light is extremely large. Speed of light is extremely large as compared to the speed of sound. The time taken by light, you can see TL, let's say TL. The time taken by light is almost equal to 0 by this calculation. So we can simply use distance equals, you can use distance equals speed of sound multiplied by time delay. Why we did this? Because the time taken by light is approximately 0. Okay, so it will be 340 times multiplied by 3. So it is also 1020 meter. So both methods give essentially the same answer, right? Remember the key idea. We see lightning before we hear thunder, of course, right? Because light travels much faster than sound. The time delay can therefore be used to estimate how far away the lightning occurred. Here the answer is approximately 10,020 meters, which we have recently calculated. Right? For more grade 11 and 12 physics concepts, numerical problems, MCQ, and study materials, visit NN Education. You can log in through nneducation.com, or simply you can download our Android app from Play Store. Thank you so much.